Have you ever really stopped to think about what's actually happening when you turn the key in your car? I mean, it's so easy to just see it as, an engine and four wheels, but underneath all that metal, it's like this incredible symphony of engineering. So let's peel back some of those layers and really take an engineer's tour of this complex machine that gets us all from A to B.
All right, so here's what we're going to do. We're going to build a car from the ground up, basically, just like an engineer would. We'll kick things off with the big picture, like what even is a car really? Then we'll break it down into its three core areas. We're going to look at the skeleton that gives you that smooth ride, then the heart that actually gives it power, and finally, we'll get to the brain that keeps you safe and in control.
So let's start with that first question. What is a car, really? Because to an engineer, it's not just one thing. It's this incredibly complex ecosystem where literally thousands of parts all have to work together perfectly. And this whole world of designing and creating these things, well, that's what we call automobile engineering.
And look, this isn't just about wrenches and greasy gears anymore. Not at all. Today, it's this incredible blend of mechanical, electrical, and computer science all rolled into one. I mean, think about it. It's like building this powerful mechanical beast and then giving it this super sophisticated digital brain, all just to create something that doesn't just move, but performs beautifully. Every single decision an engineer makes about a car is a trade-off. They're constantly playing this high-stakes balancing act. So you want a faster, more powerful engine? Okay, but that adds weight, and it's probably going to hurt your fuel economy. What about a super safe, beefy frame? Great idea, but that can make the car heavier and, well, less fun to drive. Every single car you see on the road is the result of thousands of these tiny battles between performance, safety, efficiency, comfort, and, of course, durability.
Okay, so to make sense of all this insane complexity, engineers basically break a car down into three main areas. A good way to think of them is like the three core pillars that hold the whole thing up. And here's the cool part. If you get these three things, you can pretty much understand how any car works.
So, first up, you've got the vehicle architecture. That's the skeleton, right? The physical frame and all the hardware. Then, you've got the propulsion system. Think of that as the heart, the engine or the motor that actually gives it life. And finally, you have the control systems. These are the car's brain and nervous system, the things that coordinate everything.
All right, so let's dive into that first pillar, the foundation. This is the absolute core structure of the car. We're talking about the parts that give it all its strength and, just as important, create that smooth, controlled ride we all want.
And it really all starts with one thing, the chassis. I mean, everything, and I mean everything, bolts onto this single frame. It has to be unbelievably strong to hold the engine, the seats, the suspension, all of it. It is, quite literally, the backbone of the entire car.
Now, this brings up a really cool distinction you might not think about, the frame versus the body. So the frame, that's the skeleton. Its job is pure strength and, protecting you in a crash. The body, on the other hand, is like the skin that's wrapped around it. Yeah, it adds a bit of stiffness, but its main jobs are actually being aerodynamic so it can slice through the air and keeping all that wind noise from getting into the cabin. Okay, so how does this giant metal frame actually connect to the road? Well, that's where the suspension comes in. And this system has two jobs that are basically fighting each other all the time. On one hand, it needs to soak up every bump to keep you comfortable. But on the other hand, it has to push the tires down onto the pavement as hard as it can for maximum grip and handling.
Here's the simple way to think about how it works. You've got springs, and their job is to absorb the big hit from, say, a pothole. But if you only had springs, your car would just bounce up and down forever, like a pogo stick. No choke. So that's where the dampers, what most of us call shock absorbers, come in. They're the ones that control all that bouncing. They tame the spring's energy and turn it into a smooth, stable ride.
Okay, we've got a solid foundation. So now let's talk about how we actually control this thing and make it move. This is all about direction and power. The steering system seems so simple, doesn't it? You turn the wheel, the car turns. Easy. But just think for a second about what's really happening there. Your hands are making this tiny little twisting motion, and the car is translating that into enough force to pivot thousands of pounds of metal. It's kind of crazy when you think about it. So the magic here really happens in two steps. First, you've got the steering gear itself. Usually it's something called a rack and pinion, and that's the mechanical translator. It turns the circle you make with the wheel into side-to-side movement for the tires. But if you had to do that on your own, it would be a serious workout every time you turned a corner. So that's where power assistance comes in. It's the hydraulic or electric muscle that does the heavy lifting and makes turning the wheel feel so effortless. All right, now for the fun part, making it go.
The propulsion system is basically this dynamic duo. First, you've got the engine or motor, which creates all the power. And second, you've got the transmission, which is in charge of getting all that power to the wheels.
Here's a great way to think about it. The engine is just the power factory, right? It's just churning out raw rotational force. But that raw power isn't always useful. So the transmission is like the smart factory manager. It's the one that looks at the situation and picks the perfect gear to deliver exactly the right amount of power to the wheels, whether you're trying to launch from a stoplight or just calmly cruising on the highway.
Okay, so we've built a car and we've made it go fast. Now for the final, and you could argue the most important piece of the puzzle, the systems that stop you and the systems that think for you.
Look, going fast is fun, we all know that. But stopping? Stopping is non-negotiable, and that's why the braking system is, without a doubt, the single most critical safety feature on any car. It has one job and one job only: to slow you down, reliably, every single time you hit that pedal.
And at its core, braking is just some really simple physics. A moving car has a ton of what's called kinetic energy. That's just the energy of motion. Brakes work by converting all of that motion energy into heat energy. The intense friction when those brake pads clamp down on the discs generates a massive amount of heat. And that's literally all braking is, turning speed into heat.
So, what's the one thing that ties all of these modern systems together? Well, it's the ECU, or the Electronic Control Unit. And don't think of this as just one computer. It's more like a whole network of them that act as the car's brain and its central nervous system, making millions of calculations every single second. And to make all those calculations, the ECU is constantly listening to an absolute flood of data. We're talking about information coming from over 200 sensors scattered all over the car. They're measuring everything you could possibly imagine: how fast each individual wheel is spinning, the engine temperature, even the precise angle of your steering wheel at any given moment.
So what does it do with all that data? Well, pretty much everything. The ECU is constantly fine-tuning the engine for better fuel economy. It's telling the transmission the absolute perfect moment to shift gears. It's pulsing your brakes way faster than any human ever could to stop a skid. It's even running all those new driver assistance systems. It's a wild thought, really, because it means the driver isn't the only one in control anymore.
When you really step back and look at it all, a modern car is already a pretty sophisticated robot on wheels, right? It's constantly sensing the world around it and making tiny adjustments. And it really makes you wonder, as these systems get even smarter and more connected, what's going to happen when your car's brain goes from just being smart to being an absolute genius?